Hello there, digital crew, and welcome to your second video of the week. Here's a question. How could you describe the location of a place or thing to another person? Well, a lot of the times when people ask for directions or how to get somewhere, you might say something like, oh, you have to drive past the train tracks, and then you have to drive past the Stop and Shop, or something like that, using landmarks to try and guide them. You could also say, oh, it's 20 steps this way, 20 steps that way. You could give them some sort of measurement. But is there an easier way to describe a place or how to get to it on a global scale? Because it's really hard to provide enough, you have to pass this gas station, get onto this and that and this and that and this. That's confusing. So how do we describe where something is, but like on a global scale? Well, that leads us to latitude and longitude, how we are going to describe very specific positions, and it could be anywhere, and it's very simple. So first off, this is mapping the Earth. That is the name of this unit, and so we need to talk about maps, right? Representations of an area used to show physical features and exact locations. So for example, that red star is the exact location of the high school. And we are going to be using maps a lot to discuss latitude and longitude, as well as get into the landscape features, which will come in the second part of mapping the Earth. So taking a look at latitude, this is where we will start. What is latitude? Because you've got latitude, you've got longitude. People always get confused which is which. I like to think latitude, flatitude. These are the lines that are going to run parallel to the equator, and they run like left to right or east to west. Right? They're also called parallels because they are always parallel. Parallel being lines that stack up evenly between each other and always run the exact same direction. So that means that these lines will never touch each other. If you look at the picture, right, every single line is going to have its own little spot and they never ever touch. The equator is the main reference line of latitude, and it is at 0 degrees. Then you've got the north and south pole, which are both 90. So it goes from 90 at the top down to 0, and then from 0 it counts back up to 90. So there's a 30 north and a 30 south. There's a 60 north and a 60 south. And then for the poles, right, there's a north pole and a south pole. Something cool that you can do to find your latitude is if you know where Polaris, otherwise known as the North Star, is located in the sky, whatever angle it makes with the horizon, or that line between where the land touches the sky, if you were to figure out or estimate whatever the angle is to Polaris, also known as the North Star, you could figure out your latitude. So in this picture you can see that there's an observer looking at the horizon, and the angle from the horizon up to the star is 66.5 degrees. So that is this observer's latitude. They are at 66.5 degrees latitude. Here's an example from a Regents exam. What is the latitude of the observer? You can see there's the observer here, and he's looking up at Polaris, which is 20 degrees above the horizon. Now this is the other part of it. The North Star can only be seen in the northern hemisphere. Again, a hemisphere is, well, it's like the halves. If you were to cut Earth in half, you've got a north and a south, and if you cut it down the middle, you get an east and a west. So you can only see the North Star in the northern hemisphere. So what latitude would the observer be at? Well, we know it's 20 degrees. And because it's the North Star, it has to be in the northern hemisphere. So the answer would be choice 1, 20 degrees. So we've been talking about latitude, and well, why can't we just use latitude to describe a location? Why do we need something else? The reason for that is that the locations on 40, well, they could be anywhere. Let's take a look here. We're about at 40, right, going through New York. You could be in Denver, you could be in Madrid, you could be in Ankara, you could be in Beijing. You could be in a lot of different places by just knowing your latitude. So you need something else. Naturally, that would be longitude. These are the lines that measure the distance east and west from the 0 line, which is the prime meridian. So you could think of it like the equator of the longitude, right? The prime meridian. and they're called meridians, each of these different lines. Almost looks like orange peels, right, where it gets kind of fat towards the middle, but then they all touch at the North and South Pole. Big difference between longitude and latitude. And you can see that they usually are marked every 15 degrees. So this is a little different than latitude, which tends to get marked every 10 or so, but here they usually get marked every 15. And there's a good reason for that, which we'll get into a little bit. So with longitude, there is a very interesting line. It's called the International Date Line, and it's not at 0, but it is at 180 degrees east or west of the prime meridian, the 0-degree longitude line. And it's kind of funny because it's the date line. So on one side of the line, you've got one date, and on the other, you have a different date. So you can literally jump between line, the side, the east side, and then the west side, and you can change the date based on where you jump to. So kind of funny, but also it runs through mostly ocean. So it's not a huge problem because you don't have lots of people going past it all the time. But we needed to have a date line somewhere because where does a day start and a day end? It's kind of hard to wrap your head around if you don't have something concrete, a definite line where we kind of draw where the date comes from and ends. So you've got this, and then again, here's the prime meridian, the 0, and that runs through